Good morning to everyone. My name is David Acheme from Edo State University, Uzare, Edo State, Nigeria. I want to specially thank the organizers of the conference for accepting our paper and giving us this opportunity to present our research work. My co-authors are Professor Wilson Nwankwo, Dr. Akinola Olayinka, and Dr. Ayodeji Makinde. And the topic of our research is petroleum drilling, monitoring, and optimization, ranking the rate of penetration using machine learning algorithms. Oil exploration is a major economic venture that requires enormous expertise and technologies in developing countries. And this is especially important because most of the economies of these developing countries depend hugely on revenues from oil exploitation. In this research work, we attempt to apply different machine learning algorithms in order to discover the most efficient algorithm that could be used for the prediction of the rate of penetration. The data set that was used was obtained from the North Sea oil field. And on a comparative analysis of the models, it was shown that the random forest algorithm exhibits the best efficiency in the prediction workflow, having a root mean square error value of 0.0010. Our further findings in this work also show that significant parameters of concern during drilling operations were the depth, the bit rotation per minute, the formation of porosity, the shale volume, water saturation, and log permeability. Therefore, we concluded from our research, we conclude that the research of this study provides a good template to guide the selection of machine learning algorithms to drive solutions for optimization of oil drilling operations. The drilling, here a little background, is that the drilling phase in oil production is the most expensive phase. This has been established in existing literatures, and this has led to continuous effort that have been targeted at optimizing it so as to ensure a reduction in the total cost associated with the entire drilling process. And despite the constant improvement in tools, products, and processes in optimizing oil drilling, machine learning methods have not very well been reported, and they have not played any very significant roles in optimization. This is according to Braga 2019. Machine learning models, however, in our opinion, holds promising results in this sector, as it will lead to the efficient processing of the huge amounts of data which are produced by several Internet of Things sensors at oil rigs. And those kind of models, of course, will be useful in guiding decision making. Current drilling rigs hold massive amounts of instrumentation for the collection of parameters from almost every equipment that is installed in an oil rig using sensors that measure their state, and this has led to exponential growth in the data that are generated at oil rigs. This data lays the necessary foundation for the development of machine learning models for predictive analysis and development of decision support systems. And this has also began to drive interest in developing machine learning models that will address optimization of the drilling process. However, a major challenge is what is the correct algorithm to use? What kind of models am I to use? Considering that machine learning has several models that are dependent, that whose performance are dependent on particular scenario and particular type of data that are being utilized. Therefore, this work set out to examine 18 different machine learning algorithms and to rank them based on performance in order to provide a template that shows the best performing algorithm. The work adopts the standard procedure for developing machine learning and data science models. And this methodology, as shown in figure 3.1, comprises of 5 phases, which are: we understand what the business problem is. In understanding the business problem, you want to know what you are predicting, and you want to know what are the input variables that are necessary. Then we carry out the cleaning, data cleaning and preparation, data modeling, model evaluation, and operation, and putting the model into operation. The data set and features. The data set utilized for this research work is the open source Volve data. This is a complete set of data from the North Sea oil field available for research, and it's freely available online. And the data set has 7 input variables. So the first one is the measured depth, the weight on the bead, the rotation per minute, the formation of porosity, the shell volume, the water saturation, and the log permeability. The first 7 variables, are the input variables or the features of the data, and these are also called the predictor variables. While the rate of penetration is the target variable, that is the predicted variable. On table 1 here, we have a snapshot of this data set, and the entire workflow is shown in figure 2 right here, where we collect the data. This data set can be collected from IoT sensors that are at real-time the IoT sensors are installed by the oil companies, and this data set can now be transformed, cleaned, wrangled, and then features are selected. Then machine learning models are built, and then there are comparative analysis. But a quick one here is that our own data set does, even though it follows this architecture, the source is not from IoT sensors, but from the North Sea and existing data set. We show this here to emphasize the possibility of obtaining this from IoT sensors as installed in different oil fields. Since this research work set out to develop and carry out a comparative analysis of different machine learning algorithms, the following machine learning algorithms were developed using the dataset, 18 of them, from the gradient boosting machine to the Bayesian ridge and elastic net. 18 of these machine learning algorithms were developed, and their performances were compared. In order to estimate the outliers in the dataset, this is part of the data preparation, the Cook's outlier detection was used. You are shown in figure 3. This outlier detection estimates the data point's influence. It considers both the leverage and residual of each observation. Cook's distance is a calculation. It's a calculation that summarizes how much a regression model changes when its ith observation is removed. So we use this as part of the data cleaning process. And here is a diagram that shows the Cook outlier detection. Once our data was ready, we fed them into the different machine algorithms, and their performances are compared as shown below. At the random forest, having a root mean squared error of 0.0010. As a matter of fact, we use all the outlined error detectors, or what we call performance evaluators, the MAE, the MSE, the RMSE, the R2 score, the RMSLE, and the MAPE and TT test. All of these are used, and as shown in our table here, starting from in the order of the table, random forest was the best performing in terms of the error, and the passive aggressive regressor was the least performing algorithm. So we established that the random forest algorithm was the most efficient among the chosen 18 machine learning algorithms tested with the dataset. And therefore, we carried out further evaluation analysis of the random forest algorithm. The further evaluation analysis that we carried out on the random forest algorithm included the residual plot, the error plot, learning and validation curves, and most importantly, we also consider the feature importance ranking on the random forest algorithm. We consider the feature importance ranking as very important because it is one of the things that decision makers want to watch out for. They want to know the most important feature that affects the rate of penetration, so that in the act of drilling, these features can be more focused on, and issues with them can be easily dealt with. So feature importance of the random forest algorithm is shown on figure. I didn't label this figure, but this is figure 3.2. And the decrease in the node impurity weighed by the probability of reaching the node is used to calculate the feature importance. The node probability can be calculated by the number of samples that reach the node divided by the total number of samples. The more important features, of course, have higher values. The features in increasing order of importance is shown in figure 4, and these are the measured depth. So we established from our research that the measured depth is the most important feature, followed by the rotation per minute on the surface, the shell volume, the weight on bit, and in that order. As we can see, these are the most important features to predict or in predicting the rate of penetration. In conclusion, our research work set out to find out the most important factors or the most important features that influences the rate of penetration, and this was established as the depth of the oil drill. We also set out to establish the most important machine learning algorithm in terms of performance, and we also established this to be the random forest algorithm. Therefore, providing a template for further research in deciding which machine learning algorithm should be used, and in deciding the selection of the most efficient machine learning algorithm for future research. Thank you.